Hi, everyone, and welcome to the DSS Break. It's great to have you here with us today. I'm Anna Annison, the founder of Data Science Salon, which is actually soon going to be AI Loves Data. And today I'm streaming directly from our headquarters, which is beautifully located in the heart of Miami, just a few blocks away from the design district. And we're here live every other week to discuss the world of data science, AI, and machine learning. And we chat about unique experiences and best practices with leading data professionals in a 15-minute break. And today we have a deep dive into production grade machine learning at massive scale with Ahsaas Bajaj, senior machine learning engineer at Instacart, who I'm a big user of. So I'm sure a lot of you are as well. Um, and ASOS is also recognized for designing and deploying large-scale recommendation retrieval and personalization systems that support hundreds of millions of item replacements annually, with customer satisfaction rates exceeding 95%. His work directly impacts fulfillment intelligence and has been publicly highlighted in shareholder letters for improving perfect order fill rates. Congratulations for that. That's awesome. And prior to Instacart, ASAS contributed to Samsung R&D and Walmart Labs, focusing on device AI and large-scale personalization systems under real-world latency and scale constraints. And he holds an MS in computer science from UMass and is an invited reviewer for the top AI venues, including AAAI, KDD, and ACL. And in this DSS break, we'll explore the challenges, strategies, and lessons behind building robust, large-scale machine learning systems for personalization, recommendation, and intelligent substitutions.
Thank you for the warm introduction. My pleasure to be here.
No, it's welcome, ASAS, again. It's really amazing to have you here, and I'm really excited to dive in and learn more about the work that you're doing. Can you start, though, by sharing your journey and how you got into machine learning, especially into this recommendation systems and personalization systems?
Sure. So my journey actually started in Bangalore, which people call the Silicon Valley of India. I was at Samsung Research working on-device search for Galaxy phones. And here's one thing about on-device ML, that there are brutal constraints. There are strict memory budgets, no cloud fallbacks, and the model just has the phone to work with. And that experience really shaped how I think about ML in general. I learned earlier on that the outcomes shape, or rather the constraints shape what you build more than the algorithms do. And during that stint, I found myself obsessively reading research papers to improve the search logic and the retrieval logic for the work I was doing for Samsung. And that led me to formalize these learnings with the master's degree at UMass Amherst, where I had a keen focus on NLP and information retrieval. And right after that, I joined Walmart Labs to focus on large scale personalization work. And I've been with Instacart since 2022. Now at Instacart, I lead the smart substitution system, which is the typical out of stock problem that when your item is not available, what do we suggest you instead? And we are taking hundreds of millions of orders, and we have to make fast decisions, reliable predictions that actually preserve what the customer actually wanted.
Cool. And no, that's an amazing journey. Thank you so much for sharing. And at Instacart, you work on systems that handle hundreds of millions of orders annually.
Mhm.
What are the key challenges in building such high performance machine learning infrastructure at such scale?
Yeah, I think there are three broader challenges. I'll start with the first one, which is latency. And we see latency as a very hard constraint. We're talking about some 100 milliseconds, 99.99% uptime. I've personally seen transformers getting replaced by gradient boosted trees, not because the transformers were worse, but because it couldn't meet the SLA. So the architecture we believe that ships isn't always the one that scores the most on the offline metrics. And that's just the reality. The second challenge, I believe, is the silent degradation, right? So when there is a breakdown in the upstream data, right? If there's a crash and the upstream data isn't reaching the models correctly, they don't throw an error or they don't have alerting, right? But the quality of the models degrade continuously. And when that happens for the scale of Instacart, for the scale of millions of orders, you cannot really spot check everything. So we believe like having deep observability baked into the infrastructure that can make sure that everything from data quality to modeling to evals are in place is one of the bigger challenges. And the third one I personally call is interface failures, right? So problems we believe really happens inside the model. They happen at the handoffs. So it could be between the feature store and the model, or the interface between the retriever and the ranking, or the interface between the system and the downstream consumers. So personally, I've started debugging at these interfaces, these boundaries more often, and not so much at the model weights, because we feel this is a bigger challenging space, especially in large scale systems.
No, that's a great answer. And I know that your work includes personalized replacement and fulfillment intelligence.
Mhm.
How do you balance accuracy, relevance, and speed in real world operational environments like that?
Yeah. So here's the thing. I believe context matters more than any single metric, right? So if you take an example of substitutions, what really happened behind the scene in substitutions? So there's a customer who wanted to buy something, and we don't have that in stock, right? So the customer already is very frustrated. And at that moment, a fast and a practical replacement beats a perfect one that maybe is too slow to load, or even worse, that replacement itself is not in store at the retailer, right? So we have to weigh the speed and the relevance part of it really heavily. And so just a substitution that arrives like too late is useless, and the substitution
Right.
that itself is not in store is also useless. So these are the constraints we deal with. And more than any single offline metric, what we really care about that the system should work quietly every day, right? The system should be predictable, it should be reliable, it should be contextually aware. And the customer should not notice the algorithm. And what they notice is that their order is actually getting completed just how they wanted it, right? So as you were referring initially about the shareholder letters, right? So in a recent shareholder letter, we did report that we handle more than 300 million replacements in every year, right? And the satisfaction rates are over 90%. So that's the metric we kind of track, and we wanted to get as high as possible.
That's cool. That's really awesome. Congratulations. That's a really high success rate. And a lot of those customers are now happy. So, because that's such a big thing.
Yeah.
And I know, maybe you could walk us a little bit through the design of one of
Mhm.
these large scale recommendation pipelines. How do you handle high decisions in real time personalization?
Yeah. So we actually use a classic three-stage architecture, but the devil's is in the details, and I can walk you through briefly. The first stage is the retrieval stage, where we have to narrow down from a million of items to maybe 100 candidates. So here the goal is high recall. So we have to cast a wide net with the hope that we get all the relevant products or the items in that net. We specifically use a two-tower deep learning model, and we have a blog post about that as well. If folks are more interested, they can read in detail about that architecture. But at high level, we try to embed the original item and the potential substitutes into a shared embedding space. So this tells us the items that are semantically similar to what the customer wanted, and not just the item with the matching metadata, right? So this is the first retrieval stage. The second stage is a ranking stage, where we have an ML model that predicts whether the customer would accept if you would give them the item B instead of item A, right? And this is the stage where precision matters, right? Because we want to put the best items in the top.
Right.
And again, we have moved from treating this as a catalog matching problem to treating this as a customer intent prediction problem. And that reframing actually changes everything. As I said, the devil is in the detail. So we need to really understand what you're trying to model, what the objective function is, and how it solves the actual customer problem. And on top of this is the third layer, which is a re-ranking layer. And this is where our guardrails live, right? So you don't want to recommend peanuts for allergy flagged users, or you don't want to substitute a alcoholic beverage with a non-alcoholic one. So these rules like sit on top of like the ML scores, where you don't want any exceptions and you just want some product-centric decisions. So this is roughly how our architecture looks like right now.
No, that's awesome. Thank you so much for sharing. And maybe you could share a link after we're done up to that blog post to people that are curious to see more.
Sure.
And I know that prior to Instacart, you worked on device AI at Samsung R&D. And what lessons from mobile AI translate into building scalable production grade recommendation systems, if there's any?
Yeah, actually, like there are two big ones that I still carry with me, and I use it in my day-to-day modeling work, even currently. The first one is that the simplicity earns its place, right? So as we spoke before, like on mobile, you literally cannot throw compute at problems. Like the phone has what it has. So I've actually, while working at Samsung, I've developed this habit of always asking myself, like, does a simpler model work well enough, right? Or do we really need to go and make the model much more complex? So we
Right.
have coined this term called like earned complexity, and people talk about earned complexity, that you only add complexity when you have proven that you actually need it, right? And that principle translates into multiple production systems, including recommendation systems, where we have often seen like simpler model outperform the sophisticated ones just because they were trained on the signals that actually reflected what customers wanted. So that was one big learning from my Samsung work. And secondly, like there is a lot of push on explainability, right? Which is operational, like, and not just ethical, right? So imagine if you're debugging something in the middle of the night and something is broken, the black boxes, they soon turn into liabilities. And
Right.
you really need to trace why the system made a particular decision. And while working on these mobile products, I had to convince myself, like, hey, if we are putting something in front of the customers, we should be explaining to them like why this search was ranked higher. And that discipline actually influenced a lot of my work that I do currently.
Nice. So that's a great answer. Thank you, SS. And for teams who are just starting to build production grade personalization systems, what are the most common pitfalls and how can they avoid them if they could try to avoid them?
Yeah, sure. So again, two big ones that I see consistently, right? So first one is the offline trap, right? Teams often celebrate like high AUC scores, high offline metrics, and ship things to the production, and then wonder why the business metrics are not moving. So we have seen that the offline wins, right? They don't automatically translate to online business wins. And you need to really try hard and validate your offline metrics and prove that they predict the online impact, and we have to keep revalidating this as the world changes, right? So
Right.
this is a big one, that you got to trust the metrics before you launch an experiment, and you have to continue validating that understanding that this is what we try offline and this is how it lands an online impact, right? The second big one is label ambiguity, right? For example, in recommendations, you need to be really crisp and clear in understanding what does a good recommendation mean, right? Is a
Mhm.
click a good signal, or a purchase is a good signal, or a purchase with no return is a good signal. I'll give you a concrete example from my world. So if the customer orders organic strawberry and we send them non-organic strawberry or a regular strawberry because the organic one was out of stock, and the customer did not file a complaint with us. Now, how
Mhm.
what do you infer from that? Like, was it a good prediction, or the customer just tolerated it just because they didn't have any other option, right? So defining this upfront rigorously saves a lot of effort down the road, because now you have a very clear idea of what you're trying to optimize, and then you build the systems tailored to that problem.
Yeah, no, that's a great answer. And collaboration is really critical for machine learning at scale. How do
Mhm.
you work with data scientists and engineers and product teams to ensure everything delivers real world impact these
Yeah,
days?
so yeah. We do a lot of collaboration with all these different teams like data science, backend engineering, platform, product, and we help each other out in different ways. So with data science in particular, we dig deeper into metrics, right? We try to
Mhm.
understand the state of the union, how is our ML system performing and how it's solving customer problems, what are the bigger gaps, and how does improvement in the ML performance translate to business outcomes. So that's where we collaborate heavily with data science. With the rest of the engineering, we want to make sure that there is no online offline skew, that the data that the model was trained on, the distribution, stays almost the same when the model is used real time in production setting. So we work hand in hand with the engineering teams to understand the data distributions and to monitor any skew that could degrade model performance. We work with product very heavily, right? We align on the business rules that should live outside the model, any price limits, any dietary constraints, any category restrictions, and we have this clear ownership of what the model should control and what's really hard coded in the product system. So these are some examples how we collaborate, and we do a lot of writing. And I believe writing is a big uh, powerhouse, right? When you align on ideas, when you share broadly and get alignment earlier on, it just unblocks a lot of high velocity iterations.
Cool. And are there some like tools that you use for collaboration that you like?
Yeah, we heavily rely on Google Docs.
Okay.
We have a lot of docs going around the teams, and we Gantt everything out with clear timelines. We use Google Sheets and some of the internal like Google workspaces to like clearly map out what is the resourcing looking like, which team member is tackling which problem, and when it's due. So we have a few people helping us to keep track of these things.
Cool. No, I like Google Suite. I think that's a great tool. And looking forward, what kind of emerging trends in machine learning, personalization, and recommendation systems are you most excited about, especially with AI here,
Yeah.
changing everything so quickly?
Right. I am personally very excited about the hybrid intelligence world. It may take some time before LLMs completely replace traditional recommendation systems. I'm more keen on how we can augment the benefits of the two, right? Uh, taking example, like we can use language models for cold start reasoning, for generating explanations, for handling sparse data cases, right, where the traditional ML struggles. So that's something I'm keeping a very keen eye on, like how can we add AI as a semantic layer or a semantic explanation layer on top of the traditional ML systems, where we can retain like the low latency and the cost effective benefits of traditional ML, but add a more explanation part with Gen AI, right? So it's kind of a shift between show and explain. So we are now able to explain a recommendation so that user trusts our algorithms much more, than before. And I think the big second emerging trend that I believe will be a big thing going forward is the operability, right? So our system should be able to operate in like at high scale. We should have high amount of debugging, monitoring, and we should know when we are not performing well. So it should be a graceful degradation rather than a incident middle of the night. So I think with these AI tools coming into picture, we need to make our systems even less brittle so that they don't break unexpectedly, and we are able to add like more understanding and more explainability throughout the stack.
Yeah, no, I agree. And that makes a lot of sense. And Ahsaas, thank you so much for sharing your insights into building high scale production ready recommendation systems and personalized machine learning pipelines. Your experience in bridging academic rigor and operational reliability provides a valuable roadmap for everyone working on large scale AI systems. And to our listeners, whether you're designing recommendation engines, optimizing personalization workflows, or scaling machine learning infrastructure, this episode provides practical strategies, lessons learned, and inspiration from a true expert in the field. Thank you so much, Ahsaas, again, and thanks for tuning in, everybody. And I look forward to also seeing you as a speaker at our virtual event on April 8th too. So if you guys enjoyed this conversation, you'll have to tune into that too. So, all right. Have a great rest of the week, guys.